Think like Tesla.
Think like Tesla, Micah here. My workbench is still cluttered with all these batteries, which got me thinking about power and energy. You look at a common battery like this one, it's a rechargeable, and it says 2,800 milliamp hours on it. Now that's kind of silly on one level, right? It doesn't say 1,500 millivolts, it just says 1,200. So why do the numbers get inflated for milliamp hours? It seems kind of silly to me. But there's an even bigger issue with these ratings. The rating is that milliamp hours, or amp hours, are largely useless for comparing things. There's a few scenarios in electronic design where it might make sense, but at the consumer level, it's not directly comparable. I just replaced a battery in my tablet computer, and the rating on the replacement battery said 7,000 milliamp hours. Looking at coconut battery in my MacBook Pro, it says 5,770 milliamp hours as the design capacity. So does the tablet have a bigger battery than the laptop? No, it doesn't. Now, a milliamp hour, what it really means is an amount of charge. It's a number of electrons that you can push from one place to another. And in the case of 1 milliamp hour, it's about on the order of 22 quintillion electrons. So that's a lot of little charges getting pushed around. But of course, the proper unit for energy is the watt times time. Watt hour, watt second, whatever. So we can take milliamp hours times, or amp hours times voltage. That's a good way to get there. And that's why the tablet with a 3.7 volt battery had a different rating than the laptop, which probably has 3 of those in series for the rating. So common units for energy are joules, which I think are understandable to people. They're just not in common use. And kilowatt hours on your electric bill. I think those are less understandable to folks. For much the same reason is this battery is rated at 1.2 volts. It is not described on the package as 1.2 kilogram meter squared per ampere second. That would be a technically accurate description of voltage, but not very useful. Volts are something more understandable. So can we come up with a more understandable unit of power and energy? So power, like watts, is an instantaneous value. Can't really get a lot of meaning out of that. You can, for instance, charge up a capacitor and discharge it quickly to have a lot of instantaneous power, but sustained power over time, that's what we're talking about here. So for that, I'm going to propose an informal unit of measure called a phone charge. phC, phone charge. Phone charge is not intended to be for laboratory use and for scientific papers and the like. It's intended for everyday people to have a better understanding of energy. So let's take this as an example. 2,800 milliamp hours, 2.8 amp hours, times 1.2 volts gives us 0.336 phone charges. So about 3 of these together would be able to charge a regular, typical phone once. So what are some other values we can look at? Food calories. The chemical energy in a Tic Tac is about 2 calories, which is almost a quarter of a phone charge. And yes, I glued a Tic Tac to a sticky note just for this video. You're welcome. 9 volt battery, 9 volts, roughly about 450 milliamp hours, depending on how hard you try to pull the energy out. That's about 0.4 phone charges. Typical lithium-ion battery, 1.11 phone charges. Some other units for comparison. Horsepower used to be a pretty common measure of power. 1 horsepower for 1 minute is about 1.24 phone charges, a little over 1. A Tesla Model S. The average energy per mile is about 27 phone charges to move that vehicle 1 mile. A Big Mac, has about 60 phone charges of chemical energy in it. Now, a 2012 Chevy Volt has a battery with about 1,600 phone charges in it. And a full gallon of gasoline, it's about 3.8 liters, has 3,865 phone charges in it. That's the equivalent of 33,000 food calories. So next time you're filling up your vehicle, think about that. Now, there's other ways to get energy besides chemical energy. We can use E equals mc squared and do direct conversion of matter. If we had the tech, we could. A grain of salt weighing about 1/10 of a milligram would have 250,000 phone charges of energy in it. And the World War II era nuclear explosion is rated at about 15 kilotons, or 63 terajoules, or 1,750,000,000 phone charges. That's a lot of phones. And a uranium fuel pellet would have about 2.9 billion phone charges. Now, just to give you some scale of other numbers you might hear on the news, I'm going to define an apocalypse as the energy of 1 billion World War II era nukes. Right? And that's about 30 going off every second for a year, which I think you would agree would qualify as an apocalypse. That amount of energy. And then we get to thing on the news, warming the Earth by 1 degree C. That's equal to 88 apocalypses. So next time you hear people talking about global warming, about warming the Earth, maybe you'll have at least some kind of a more intuitive feeling for how much energy we are talking about in this. You come here for Tesla Facts, but now freshly out, Veritable Reality from the Tesla Chronicles, Tesla Fiction. I would be honored if you would go check this out. Links in the description below.